So if I factor the numerator and the denominator, on top, if I'm going to factor this, I'm just looking at x minus 1. Do they have anything in common? That's always the first thing we look for in factoring. Do x and minus 1 have anything in common? JC? Right. 1 would be the only thing they have in common, and when we factor things, 1 is not helpful, which means that x minus 1 can't be factored. However, on the bottom, the denominator, we definitely can. Someone raise your hand and tell me, if I've got a 5x and a minus 5, what do they have in common that I should be able to factor out of this? Only a couple people see this so far. I've got a 5x and a 5. They should definitely have something in common. Grace? They both have 5s. I'm going to factor out a 5. And if you remember, when we factor out a number, we divide what's left. So if I did 5x and I factored out a 5, I'm left with 1x. If I had a minus 5 and I factored out a 5, I have a minus 1. And now we have something that's much more helpful. So there were a lot of people at the beginning saying, well, can't I just cancel x on the top and x on the bottom? And you cannot. And there's a reason for this. The x that's on top and the x that's on the bottom are not separate factors. X is not a factor of x minus 1. I can't just take this random piece of that number. It would be like if I asked you to reduce 12 over 19, and you said, oh, there's a 1 and there's a 1. I've got 2/9. All right, that was easy. And we all know that's completely wrong, right? You can't do that. You don't just take part of the number. It works the same way with polynomials. X cannot just be taken out separately and canceled with this x that's here. That's the same as just doing this. So we can't do that. Instead, we have to factor out everything that we can, and then we cancel entire factors. So now that we factored it, something should obviously match. What is it? Leo? Which two things match on the top and the bottom? The x what? There's more to it than just the x. X minus 1. The entire binomial x minus 1 on the top and the bottom cancel out together. And the only thing that I'm left with is a 5 on the bottom. But we don't just leave it blank on the top. What number do we put if everything else is canceled or everything else has been reduced? Chris?
1.
We put a 1. So as we said at the beginning when I said pick any number you want and plug it in, any number that you plug into this, because it factors out and cancels this way, should always give you 1/5. So to simplify this, we now have 1/5. We did, however, say there's an exception. Chris tried to plug in a 1 earlier. If you try to plug in a 1 right now, you can do a little mental math, you'll see that it does not even come close to being 1/5. It becomes 0 over 0. That's not even close to 1/5. So, we talk about why and we talk about what that means. There's a problem with just saying that any number can be plugged in. There's oftentimes exceptions to this. The problem comes up from this, the fact that we have a fraction. What number, raise your hand if you know this, what number can I never, ever have as a denominator in a fraction? One number exists that is a impossibility. You can never have this number as your denominator. DJ? 0. You can't divide by 0, so 0 should never be your denominator. So what we need to do is find what are called excluded values. Excluded values are the numbers that you can plug in that turn your denominator into 0. So these are the numbers that make this expression mathematically impossible. So what we want to find out is what number would I plug in for x that would make it equal 0. And I only care about the denominator. I never care about the numerator for this. The denominator cannot be 0, so let's find out what number would do that, and that's what I'm going to avoid. So we set it equal to 0, and we solve like a regular equation. I would add 5, so 5x equals 5. I would divide by the coefficient and get that x equals 1. So what we found altogether here is that you should, no matter what number you choose, if you plug it in, it will reduce down to 1/5, except if x equals 1. So to write this as one full answer, we say that this simplifies down to 1/5, and x cannot equal 1. So as long as x is any other number, it will always make 1/5.